Redundancy covers all areas of an application stack. Now that means pretty much everything. And again, if we're talking full redundancy, there's obviously different layers or levels of redundancy. We don't necessarily have to have everything, but if we want to truly have a fully redundant environment, then that means our servers have to have everything redundant, the power supplies, the RAID environment, okay, the disks that make up that server, the NICs, the network interfaces or the HBAs, our network switches or fabrics, depending on if it's an IP or a fiber channel network, the storage arrays themselves. All of these things need to be redundant. And as you can imagine, that gets very, very expensive. So that's why businesses typically are selective in what they have fully redundant, if they do it all right? Because a lot of times everybody wants to have a fully HA environment, okay? In case something happens, they want to have that insurance policy, but then when it comes down to the actual rubber hitting the road and you ask the business to pay for that redundant infrastructure, then all of a sudden it's like, well, we don't really need that. Let's look at some other alternatives, or let's look at something else that we can do instead of that. And the reality is, some things can take the place of that, but there's really nothing that can take the place of a fully redundant environment for HA, ultra high availability, limited disruption environments. So redundancy comes down to a couple things. We have clustering. And again, with clustering, we have multiple servers that operate as one. Okay, they operate in concert. MS SQL Server, Oracle RAC. Okay, there's a few instances or a few examples here of database infrastructure that can operate in a clustered environment. So you have multiple servers that act as one. Okay, it allows for some additional scaling and some load balancing. There's also hot spares is another concept where data is copied over proactively. All right, so clustering is a server-side concept, right, between SQL Server and RAC in this example, or the hot spares themselves are the actual data, or the disk drives in those servers, whether it be SQL Server, RAC, or if you have it out on a storage array or a NAS device. Those disks within those devices are basically extras, all right, quote unquote. And those things are there for the old in case of emergency break glass type of thing, except no one has to go out and proactively break the glass and replace those drives. The hot spares sit in the array, and as soon as the array itself, it has enough intelligence to understand that, hey, my disks are failing, or this specific disk is having some issues, let me now start that sparing process, and it will copy over the data off those disks. It will be proactively moved from the bad disk to the new disk. All right, so spares can be dedicated disks themselves, or they could be space on multiple disks. All right, so basically like a hot space, if you will. All right, so it doesn't necessarily have to be a dedicated disk. So each array and each manufacturer has a different number of requirements, or what's the best practice for the number of disks in those arrays. But you always want to maintain X number of spares according to best practices, so that when you do have failed drives, that data can be copied over proactively, and then the array should have some type of intelligence that will phone home, quote unquote, either back to its vendor or the actual storage array manufacturer and say, hey, I have an issue, here's a bad disk, and that will start the dispatch process, and they'll get somebody out to your site, depending upon, obviously, your service contracts and so forth, but they'll have somebody come out and replace those drives for you. So again, something that definitely needs to be monitored. It needs to be set up properly so that the admins themselves are aware. But the concept of a hot spare is definitely critical or crucial to a redundant environment. All right, and as we see here, redundancy can be in a third area. Let's say, for instance, we have our clustered servers, right? We can see we have a couple web servers down at the bottom. We have two different switched networks, all right? And we have an internet router, basically something coming in from the outside. So they're going to hit a bunch of web servers, and in the database server on the back end, they have what in the middle? They have a load balancer, and that load balancer, again, is redundant. All right, so that allows people to come in, especially if we have a very hot environment, we have lots of requests coming in. That load balancer will either round robin and serve requests to the various servers, or depending upon the algorithms that are in that specific load balancer, some are better than others, obviously, that they will proactively look and see which server is least busy and then send data and send traffic to that specific server. So it allows you to spread the load, hence the name, across multiple servers so that no one server really gets overwhelmed.